So here we have special formulas and factoring. And we've already learned these formulas when we were going in this direction. And when we go in this direction, that's called multiplying. If we take them and we pull them back out into their factors, we factor them out, that is called factoring. So you've already worked with using the formulas in this direction. Now we're going to look at actually going backwards with those formulas. So the first one we'll look at looks like this. You have 16x squared minus 25, and it says factor. And this is the difference of squares. What I notice is that there is a difference, which means subtract, and there's squares right there. So we're actually using this formula right here, which says that if I have a squared minus b squared, that's the same thing as saying a plus b and a minus b. So when I look at this, I can say, okay, well, this is 16x squared. Well, that's the same thing as saying 4x squared. Minus 25 is the same thing as saying 5 squared. So if I look at the formula, 4x is acting like my a, and 5 is acting like my b. So I just rewrite my formula, substituting 4x for a and 5 for b. So if I put 4x for a, I'm going to have 4x plus b was my 5, and then a is 4x, and my b is 5. So here is my answer. That is how we use that formula. So the key thing is to know which formulas you're looking at. Here's another example. Example 2. I have 16x to the 4th minus 81. That's the same thing as saying 4x squared minus 9 squared. So 4x squared is acting like my a, and 9 is acting like my b. So I will go ahead and write 4x squared plus 9 times 4x squared minus 9. Now I look at this carefully, and what I notice is I can keep factoring. This one doesn't go any further because it is not the difference of squares. This formula only works for the difference of squares, so be careful because that is tricky. This is the difference of squares, though, so I can continue with this one, and that's the same thing as saying 2x squared minus 3 squared. So I'm going to have 4x squared plus 9, that's my first part, still stays there, and then I notice that this piece here can be broken down into 2x plus 3 times 2x minus 3. I cannot go any further. There's nothing else that will factor, so that is my final answer. Okay, let's take a look at one of the other formulas. So here, if I had 25x squared minus 60x plus 36, this is the formula that I could use, a squared minus 2ab plus b squared. So I need to make sure, well, what is my a and what is my b? And when I use this formula, and that's going to turn out to be a minus b, all of that gets squared. So I notice what's acting like my a is, well, this is the same as saying 5x squared minus 2 times 5 times 6, because this is going to be 6 squared. So if I'm looking at that, I do have that because 2 times 5 times 6 is 60. And so my a value will be 5x and my b value will be 6. So I can write this as 5x minus 6, all of that squared. Now if this had been 61 right here and not 60, this formula would not work because then I would not have had 2 times my a value times my b value here. So this has to equal 2 times whatever your a times whatever your b. So you need to be careful when using that formula. Now we'll take a look at solving equations by factoring. So here's the steps that we do. First, we set our equation equal to 0. Then we factor. Then we use something called the zero product property. And the zero product property says that if I have a times b is equal to 0, then either a must be 0 or b must be 0. They could also both be 0, but one of them has to equal 0 if two things multiplied equal 0. And then you would just solve your equations. So let's take a look at what we have here is an example. So let's say I have x squared plus 5x equals negative 6, and this would say solve, because I now have an equation, and whenever we have equations, we are going to solve. This is called a quadratic equation because it is squared. So I'm going to solve this quadratic equation. Well, the first thing I notice is that when I'm going to solve this, I am going to set this equal to 0. So to set this equation equal to 0, I need to add 6 to both sides. So I add 6 to both sides, then this equation is equal to 0. Now I'm going to factor the left-hand side. So when I factor that, I get x plus 3, parentheses, x plus 2 is equal to 0. Now I'm going to use my zero product property, which means I'm going to set x plus 3 equal to 0, or x plus 2 is equal to 0. Then I'm going to solve these linear equations. This was called a quadratic equation because it had a square. These are called linear equations because they just have x's. So x plus 3 equals 0. When I solve that, x is going to be equal to 3. X plus 2 is equal to 0. When I solve that, x is going to be equal to actually this should be negative 3 and negative 2. I can always check my answer by substituting it back into my original equation right here. When I substitute it back in, I will find out that it's equal to negative 6. Here is another example, example 2. I have 2x squared minus 5x equals 12. So my first step is to set my quadratic equation equal to 0. To do that, I need to subtract 12 from both sides. My next step is to then factor, and when I factor this, I get 2x plus 3 times x minus 4 is equal to 0. Then my next step is to use my zero product property, so I set 2x plus 3 equal to 0, or x minus 4 is equal to 0. Then I solve this. So to solve this, I'm going to subtract 3 from each side there, then divide each side by 2, and I get x equals negative 3/2. To solve this, I just add 4 to each side, so I would get x equals 4. So I have two answers. For your answer to be complete, you would need both answers.